Hey, welcome to Video Bytes. I'm Ethan, and today we are with Mike Lossmann, technical evangelist at Forward Networks, and we are going to talk about intent. What are they, Mike? You call them intent, not changes. What's the word?
Checks, intent checks.
Right. Okay. And the big idea here is with forward intent checks, we can really get a big head start on troubleshooting when things are going wrong. And so in this demo, you're going to show us intent checks. You got to break something and then leverage those intent checks to make the troubleshooting process go much quicker than they normally would. Have I got that about right?
Yes. So kind of like what I'm going to do here is I'm going to make a change. But the change is going to break something that the change has nothing to do with. So imagine you're in a change window, you make a change, everything looks good where you made the change on the path and everything. You go home and then you get a page at 2:00 in the morning saying, "Hey, we have a site down. What happened?" And then you're sitting there all groggy-eyed because you just went to sleep, and you're like,
I'm laughing at the 2 in the morning because it always is 2 in the morning. I've literally gotten a call at 2 in the morning. Yeah.
So have I. It's like, I don't know what happened. And then you're starting from square zero. What if you had what the network should function like, and then you make the change, and then you get the snapshot of that network, and then we can show you if there's an intent check, what failed, and then we can step through how we can figure out where the problem was.
Cool. Okay, let's jump in.
All right. So what's the one thing in networking that's kind of the only thing that's changed in the last, let's say, 5 to 10 years? That's complexity. Networks aren't getting easier to manage. They're getting more and more complex. And every time I see this slide, I love pointing out that the enterprises I worked at, I wish my network was as clean looking as that. But let's face it, they're not. We need to worry about all this stuff, multi-vendor, security incidents of those multi-vendors. What happens with outages in a multi-vendor environment? You have Bob who sits in the corner who knows where all the skeletons are. That's that siloed knowledge. What if Bob's on vacation and something happens? Just networks aren't getting any easier to manage. Tens to hundreds of thousands of devices, constant change, new technology going in. There has to be an easier way to holistically look at a network and get the data you want out of it. And that's where Forward Networks comes in. So how do we work? So what we do is we connect to all layer 2 through 4 packet pushers, and we get the device config and state. Read-only access, never write. We support 28 plus vendors, a whole bunch of OSs, all 3 public clouds, and more than 900 OS variations between that.
You guys are modeling my network soup to nuts with, but not just like, oh, there's a load balancer here. It's like, an F5 box, let's say, deeply, and you can understand VIPs and rule sets and transforms and all of that, and 100%. Can then replicate a packet flowing through that modeled network end to end.
So that's the cool thing, right? So when we get all this data, we get it via SSH or API, depending on the platform we're connecting to. We run that through our mathematical model, and out comes a digital twin of the network, right? So when we take that data in, not only do we put it through the math model, we normalize it and we put it into our data model. So you don't have to be an F5 guru, a Cisco guru, a Versa guru, or whoever to get data out of it. It's one standard query language that you can get data out of it. But the cooler thing that we can do is we can analyze everywhere a packet can go without ever sending a packet through the network.
Just through the production network, you emulate it all in the network model using math and figure all of that out. Okay, so that's good context. So you're setting up that what I'm looking at with the Forward Networks demo that we're going to see here is a model of a production network, and demonstrate just how accurately you can use that model to surface issues, surface problems, and what's really going on to help an engineer troubleshoot without. Well, when you put that first this slide up here about the slide that had the complexity on it, I'm laughing because it used to be back in the day. I used to have the whole network in my head, right? And I was the guy with the digital twin. It lived up here.
Same.
And
100%.
Yeah, and it's gotten to the
totally
point of you just can't remember all the things that are things at this point.
It's growing too fast for any human to remember what a network looks like and what a network can do. But the bigger thing is, right, that we can scale to 50,000 plus devices, right? We have some extra large enterprises that have 60, 70,000 devices that we're actually collecting from.
Okay, so you basically you're hitting pretty much any network of whatever size. I've worked on a lot of networks, thousands of devices, yes, and I've never been as big as 50,000 as far as that goes. So okay, you're networks of scale, got it.
Correct. So what we're actually going to do is I'm going to switch real quick, and we're going to take a quick look at the environment that I'm going to change. So this is Forward App. We're going to jump into the Atlanta data center, and we're making a change to this border leaf. So the network manager, in his infinite wisdom, had seen that there was a lot of route maps sitting on this particular network, and he wants us to start cleaning up route maps on network devices, particularly going towards our extranet switches, because we don't need to advertise specific routes. We want the extranet to have everything, right?
Cleaning up is good. I'm a fan. Yes, I like this.
But before Forward, like, to get this change, it would induce fear in anybody, because you don't know what's right. You don't know if you're going to get that page at 2:00 in the morning, and I like sleep. So, all right. So we're going to make a change on the BGP neighbor pointing to this guy. So let's do that. And this is as live can get. Did my keyboard fall asleep? No. Good. All right. So we're going to and old habits die hard. I tend to hum and talk about the commands that I'm typing.
Okay.
All right. So we're going to do no route map. Advertise out.
Okay, so you just eliminated the route map going to that neighbor 10.180.2.2 entirely. So whatever routes were in that route map, we're no longer announcing them in that direction.
Correct. We're not filtering the routes going in that direction.
Gotcha. Okay.
We're going to clear the BGP. Oops. See, even the best of us still forget syntax every now and then.
Yes, we do.
So we made the change. Now, before Forward, what would you do to verify that this change was good?
I'd log into a bunch of things and validate that the routes I expect to see in various routing tables are where they're supposed to be in various VRFs and so on. I have kind of a laundry list of all the different devices I think I'd want to touch to make me feel like, things are going good.
Okay. So what I'm doing is I'm doing that, but I'm doing that on an entire network scale. So I actually launched a collection, and just in the spirit of being transparent, this collection is going to go pretty quick because this network is small.
Oh, okay. So you just hit 80 sources. That went amazingly quick. If I had a huge network with 25,000 devices in or something, how long would this take?
So that depends on the complexity of like the network, but typically we see our extra large organizations that have 25,000 plus devices can do a collection in anywhere from 30 to 40 minutes.
Okay. So, and that data collection is you're logging in and with pulling a bunch of show commands if it's a Cisco network, let's say, or maybe doing a bunch of API calls you're pulling a bunch of state out of the network, right?
Correct. Config and state. That's how we feed the model. That's how everything looks. So now we can collect probably faster than how you can verify that small part of the network that you're actually looking at, plus do the verification on top of that if you have the right verification checks done or in the system. So let's see. All right. So the collection's done. Okay. What it's going to do right now is it's going to process the change, or it's going to process everything that we took. And this is where the magic happens. So this is where it gets put into the model.
So we had a previous snapshot. So now we're processing the new snapshot, and we're going to get to see diffs?
Yes, we can see diffs. That's going to be part of the coolness that I'm going to show you when we start looking at the thing that maybe broke, maybe didn't broke, or broke. It's Monday. Maybe didn't break. So we noticed one thing did change from before to now. And there is now a red dot next to intent, right?
Okay, intent being these are checks or kind of like tests that would have been previously written and now something's red, so maybe something's failing. Is that what that means?
Correct. So these nine verifications, just a small piece of what. Oh, and we also got a little bell alert saying that we have 2 new verification failures. So we'll get back to him in 2 seconds. So what this is showing is this is the intent of how I want my network to look. So let's look at one that's good. So essentially what I'm saying is all of my Atlanta PCI hosts going to my GCP PCI environment on these specific ports, there must be one path going there and at least one symmetric path coming back. So we can see that in this specific snapshot, this guy is fine. So that change didn't break him because we have passed straight down the line.
Okay.
But now let's see what failed. So we did have a failure that is actually not even in the data center. It's in a different site saying that this host now going through this firewall cannot access something that's in the data center. So let's see what happened. We can go to the diffs in several different ways. We can go to the diff.
Okay, just backing up a second. This is counterintuitive because we were in the Atlanta data center making the change, and this is now just reading this here. It's St. Augustine. So we've we've created an unexpected problem, I think we're saying.
100%. So that change had an effect that we weren't expecting that change to have.
Yeah. All right.
Typically, you'd want to see the issue in the data center, right? You make a change to the data center, something happened contextually in that data center, in like a 2 or 3 switch or device radius of that data center is typically where the issue will happen. Now we're saying this is in a completely different location where this issue is actually being like noticed. So not something you probably would have had a test plan for during your change window. So now to look at the diff between the two of them, we can either click on failed here, or we can click on this view verifications diff.
Okay.
So we'll go to that guy. And what it's going to tell us is, let me move this window out of the way real quick. So it's going to tell us one device changed. And if we actually unify it and go to where the actual change is, exactly what you saw me do. We pulled out that route map. But why did that affect something in St. Augustine? Now, because we get configured.
We have a hint of what the problem might be, but still from our network engineer brains are like, this shouldn't have affected anything. So what's going on? Yeah.
Correct. So not only can you do a diff on config, you can also do a diff on state.
Oh, okay.
So now let's go. So now let's look at that firewall.
Well, wait. Okay, so I can do a diff on state. Okay, that you can always. There's so many tools that give you a diff on config, right? Because that's like low hanging fruit. That's easy. Oh, look, there's 2 text files, and you highlight the differences. No big deal. But change on state is the thing I would have been logging into all the devices and computing in my own head. Why don't I see this route here? Or why do I see this route here instead? Or whatever. Okay, but you're going to show me that here.
I'm going to date myself real quick. Back in the day, Notepad++, have 2 of them open. One pre-change, one post-change.
Yeah.
And then you eyeball and see what the difference is. That eyeballness is gone. Getting that state is gone. Now it's all done in the twin when you actually do the collection. So what we're going to do is we're going to look at what's changed on that St. Augustine firewall. Specifically, let's look at the IP fib and let's unify them again and let's see what changed.
What's the unify thing doing?
So unify takes the takes like the pre-change snapshot and the post-change snapshot and lays the diffs on top of each other.
Oh, okay. So instead of side to side, now I I can go vertical and see stacked 2 different files combined and more easily.
And it's
see
a lot,
changes.
yes, and it's a lot easier, at least for me, to see that the route came out, but nothing went back in.
No, it is. Now that I know what I'm looking at, yeah, it is easier for sure. Yeah.
All right, so now we know the route was removed. So we can jump to his neighbor, which is actually a VPN tunnel in Atlanta. So
is the 10.255.255.0/24 route? That's the one we're talking about.
Yep, It's this guy right here. He's gone.
So in the fib on this firewall, and where we have the problem, the St. Augustine firewall, we're missing a /24. Okay,
correct. And now this IP address, I so happen to know, is his peer on a Atlanta firewall.
169.254.249.1.
Mm-hmm.
Okay.
This would go into IR03. So now we can look at the same thing. So let's look at VRF routing, and let's see if that route is still here. There's a lot in here, so let's just search. All right, so we see the route was taken out, but the route was re-added back in. So if the route's there, why isn't it getting learned on the other side? So let's take a quick peek and see what that route map was doing. So let's jump out of him and let's find.
That's funny you say that, because we just deleted the route map. We never did look at it. Yeah.
Ticket came in. People said they looked at it. People said it wouldn't cause a change issue. So we just assumed that everything was good, which has happened. I have seen that happen in the real world before, where people are like, oh, the change said it did it. And, Bob looked at it and Bob said it was good. So I just changed it. So it looks like that advertise out not only was restricting routes, but it was also setting communities. Communities.
Yeah, boy.
Now,
okay.
Did someone misconfigure that firewall to not accept everything from a extranet router? So rather than go to the map, let's just search for it. USSTA firewall 01. The name, quick search, pulls it up. Just like Google, as you start typing in a name, it'll auto-suggest what it thinks you're looking for. So we'll go to config. We'll search for policy, and look at that. This guy is.
I see match community regex. I see. Yeah.
So here's Match Atlanta Data Center Web, DC infrastructure PCI, and it's applied to the BGP peer that's on the VPN, which is why the route was removed, but it was still on the VPN router. This firewall's getting it, but it's not accepting the route because it's not tagged with the community that it needs to in order to go in.
And the only way to get that, so now we know the core of the problem. So coming up with a solution to the problem is a different dilemma, but at least we know what the issue is.
So we know.
That's obtuse. Look at the length of that policy, that firewall configuration policy for BGP. Goodness. Okay.
It's wild. People like route maps these days, and people love community. So it's like, there it is. So somebody mistakenly put a WAN policy on a VPN BGP policy.
Okay, so my next steps are whatever. But have I completed what I can do here with the with forward, getting me to the bottom of the problem?
100%. So if you would have gotten this page at 2 a.m., this probably isn't the first thing you would have looked at. You would have tried troubleshooting in St. Augustine. You would have started at the switch. You would have saw that the route is actually still in the switch. So if we jump to what St. Augustine looks like, so St. Augustine is actually dual homed. So this guy goes to a VPN tunnel back to Atlanta, where this guy actually goes to the MPLS network, which goes into Atlanta. And if you look at the core switch, and if you're actually looking at the core switch's routing table, it's still there. So if you started troubleshooting from the host standpoint in St. Augustine, you'd get pings that wouldn't reply because the traffic in this instance is going out this WAN link. But when it hits the data center, it's trying to come back through the firewall, and it's being blocked because the firewall sees it as a half open connection.
Has no state for that one. Yep. Yep. 100%.
So with that, intent verification, right? So you saw like you saw the like alert coming up here. We can also send emails if that happens. We can also link it to a ServiceNow ticket too, where if the incident does come up, that a ServiceNow incident can actually be spawned. And then you can attach the incident to the change request to show, hey, listen, we tried this, but it failed because of this. And now we have to go back and reconfigure that firewall to not have a WAN policy on a VPN link.
Slack notification if I do chat ops?
Yes, there is a Slack integration with it. Yep.
Excellent. Okay, Mike. So we've got all these intent checks that you've built in here. We can alert when an intent check fails. A bunch of different ways to do that. They're going to flag things, hopefully before it becomes a critical situation and so on. Mm-hmm. Awesome. How do those intent checks get created? Is this something that are like baked in checks, or am I writing these because I'm familiar with my environment and know what behaviors I need to be checking for?
So this is daunting when enterprises that we deal with look at this, because they're like, I don't know what application flows I have, right? It's all like, I need to figure that out. The way that I would say to start with that is the way that I would look at this on a change by change basis, right? So these checks could legitimately be what you would check in a change window if it was going to affect that data, right? Mm. So let's say we change that firewall between St. Augustine and like Atlanta. What's the one thing you would want to check communication for? You'd want to check communication to make sure that those hosts are routing the way that they're supposed to route. So these intent checks can be built up, at least in my mind, over time with what your standard change policies can be. Because you never know when you make a change, could that change break the intent of something else?
It's the kind of it's the mindset you need to be in when you're building a network monitoring station, for example. Mm-hmm. Similar sort of a thing. Sometimes you don't know what to monitor until you run into that situation. Now you know, okay, going forward, I'm going to be monitoring out discards on this particular switch line card because reasons. We had this problem once before. I need to stay in front of it. But you wouldn't have known that ahead of time. So similar thing here. Each time you do a change, you think, you know what would be good? An intent check that enforces this as, and then you've got that in place and already running, and something you don't have to think about or be concerned. Wow, this would simplify future checks, wouldn't it? Because you know you've already got those intent checks in place. That could actually be part of the change control. Hey, we've already built intent checks for these half dozen or 10 things. We're not going to check them by hand, but we will check with the forward networks interface that everything is still green before we move on to the next step, something like that.
Yeah. Yep. 100%. Yep. So it's that's kind of like how I look at this, right? Occasionally you build application or you build connectivity where you know what the expected path is, right? Where hey, I want to make sure there's at least something from this guy to this guy on this port. There's times when you don't. There's times when you go into a change and you're like, oh, let me just have the app guy hey, app guy, what do you care about in this change? What do you care about change to change that never breaks? It's kind of breaking down those silos and talking to the other teams to understand what is their expected behavior of this particular application. And once it's in here you never have to worry about it.
I end up being able to use forward networks as a part of my change control. It can be a checkpoint. Okay, we're going to get this far. We're going to take another snapshot, see how we're doing, and then we're going to move on. Is that possible?
Yeah. As long as your change window's long enough. Yeah.
Right. Okay. Depending how big your network is, right? If you've got a huge network and it's going to take 30, 40 minutes for the entire snapshot to complete, then you need a certain amount of time. But particularly for smaller networks, then it becomes a straightforward thing. Mm-hmm. Wow. Okay, Mike, this is a cool demo. Whenever I see something that actually affects network operations and how I would do things day to day, I get excited. And this is one of those things that actually matters. I can actually see immediately, wait, I would change this process. I would change this process. I would do this differently if I had this tool in my arsenal. So I appreciate that. Thanks for the demo.
No worries.
People want to find out more. Where do they go?
They go to forwardnetworks.com, learn more. Hopefully this is on before Cisco Live. We're going to be at Cisco Live US in San Diego. If you want to stop by the booth and say what's up, I'll be there in the demo theater giving demos every hour.
You're going to be tired is what you're going to be. Thanks for joining us, Mike. And thanks all for listening. If you got questions or comments for Mike, you can reach out to him on LinkedIn, leave a comment in the YouTube video, and tag us, and we'll get back to you as soon as we can. Thanks for watching.